chapter 4, or rather integrals, I should say, integrals, those really, I guess, break down into two types. So the first type is something called a definite integral. And this is really what section 4.1 and 4.2 is about. So this is what you watched videos on recently. The second type is something called an indefinite integral. And for the indefinite integral, that's in like section 4.3, section 3.9. So we're going to talk about this stuff next week. Okay. Originally, I had planned to do 3.9 earlier, but I ended up rearranging the schedule and delaying that. So we'll talk about that next week. All right. Right now, we're really going to focus on this definite integral situation. And what was the definite integral? Well, I think there are maybe 3 or 4 videos to watch, but I can explain the rough idea. So the rough idea is this. Let's say you have your x-axis and your y-axis like this. And then you have some interval AB like that. And then you have some curve y equal to f of x. Then what we can do is we can figure out the area underneath this curve. So our concern is, what is the area? And this is what a definite integral is about. So, we want to find the area under a curve. Y equal to f of x from x equal to a to x equal to b. Okay, so that's really the direction that we're going in. So let me bring up that worksheet. And I kind of want to reference this picture right here. So this is at the bottom of page 4. So when you look at this picture gives us an idea of how we're going to approach this problem. What we're going to do is, here's A and here's B, and here's our curve F. We're going to first approximate the area underneath the curve by using rectangles. So if you look at this picture, they've approximated the area under the curve in 2 different ways, 2 different sets of rectangles. Okay, but this is going to be our general strategy. So the first thing that we do is we approximate the area with the sum, I guess, singular, the sum of areas of rectangles. Okay. So in order to do this, we really need to understand how to calculate the area under a rectangle, of a rectangle. So if you have the area of a rectangle, that area is just going to be the height of the rectangle times the width of the rectangle, right? So if you had a rectangle that looks like this, you'd have the width at the bottom, you could have the height at like this on the side. And then you want to find this area right here. So we're going to multiply those 2 things together. Okay. So that's our goal. So when you look at this section, the first section is all about approximating the area. And then 4.2 is calculating the actual area. So that's the difference between the two, but they really kind of tie in pretty closely together. So my hope is that I can talk about both today, and then we can work on some practice problems when we see each other on Thursday. So that's my approach. So I don't want to call this number one. I want to call this like, this is what we're doing in section 1.1, section 4.1. That's what we're trying to do. So I want to break this down in further detail for you. So let's say we're talking about section 4.1. There's a few things I would do. You know, you have to identify your function y equal to f of x and your endpoints a, b. Okay. Then the first thing we want to do is we want to chop up this interval a, b into n equal pieces. Okay. And when you do that, you're going to get the width of a rectangle. So the idea is, you know, here's A, here's B. You chop it up into 1, 2, 3, 4, 5, 6 equal pieces in this case. So in this picture, I have n equal to 6. Then the second thing you want to do is you want to find the width of the rectangle. So the width of the rectangle, that's going to equal to delta x. And delta x is just b minus a divided by n. You should put parentheses around the b minus a. Okay. So what we're really saying is that if you looked at any width right here, that's what I'm calling delta x. So this is delta x, that's 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 delta x. Okay. Is there any questions about this so far? Okay. So so then the second thing that, I mean, after we found the width of the rectangle, what we want to do next is we want to formulate something called the Riemann sum. Okay. And what this is this is the sum of areas of n rectangles. Okay. So you can think of it like this. So we have this idea of sigma notation. So this word sum, when we want to add a bunch of things together, we represent that as a sigma like this. And then we're going to have a counting variable I at the bottom. And I is going to start at 1 and it's going to go to n. Okay, so this notation means the sum as I goes from 1 to n. So in order to really be able to formulate this Riemann sum, we first need to master this notation here. So let's take a look at our worksheet. The first part of the video was really trying to help you master this notation. So let's take a look at these examples here. The sigma means we're going to add stuff together. Our counting variable is I. We're going to start at 1 and we're going to finish at 5. So because this is saying there's just an I here, that means we're going to iterate through each of the I's. So when I is equal to 1, you get 1. When I is equal to 2, you get 2. When I is equal to 3, you get 3. When I is equal to 4, you get 4. When I is equal to 5, you get 5. So iterating through all those things, we get these 5 numbers, and then we're going to add those together. So that's what that notation means. Okay. Take a look at this one in blue. This time we're not starting at 1, we're starting at 3, and we're ending at 5. And this time, for each one of them, we're not going to plug in the number I. We're going to actually take the number I and we're going to square it. So when I is equal to 3, we square that. When I is equal to 4, we square that. And we finish at I equal to 5, like that. Then we just add those results together. So if I wanted to do it in general, I could just call, AI like some sequence of numbers. Then as we iterate through, as I goes from 1 to 5, we're just going to get A sub 1, A sub 2, A sub 3, and A sub 4, A sub 5. We add it together. All right. So I just want to check that you understand what I'm saying. So why don't we try this? I want you to do the sum as I goes from 2 to 4, and I'm going to put a 3i here. And I want you to calculate what that result is. So you could write out what the sum is first and then get some number. And I want to give you a couple moments to try that. So let me write it out for you. The very first term should be 3 times 2. The second term should be 3 times 3. And the last term should be 3 times 4. So that's going to give you 6 plus 9 plus 12, which gives us 27. And that's what you guys got. All right, great.